investigations. First one's into cosmic rays. We've been taking with a Geiger counter, pointing up at the sky and finding out what sort of count we get after half an hour. And we've done that at sea level and then about 350 metres and about 108 metres. And we're getting a lower count rate at sea level than we are higher up. Now that surprised me because I didn't think a couple hundred metres would make much of a difference. We've only done one investigation at the higher one. We've done about 5 at the lower one. The one in the middle doesn't show any correlation at all. And so I'm going to use this with the Key Stage 4 kids, because with the things like the controlled assessments where they have to analyse data, our kids are quite poor at this. There's a pattern within the lower one in that at different times of the day we are getting higher rates. We're getting higher rates in the afternoon than we are in the morning. Now this presumably is because we must be pointing towards some constellation which is giving out a higher cosmic ray or something like that. But again, to see if the kids can pick up that within the main trend there are patterns within it. So that was the first investigation. The second investigation was microclimates, where as we went up into the mountains, every 50 metres in height, I took the altitude, the pressure, the wind speed, the temperature, the chill factor, and the humidity. And that was interesting because the temperature consistently dropped as we went higher. The barometric pressure dropped. The temperature fluctuated depending on what the wind was doing. And the humidity after about 150 metres was 100% because we were in the rain cloud. I also took GPS coordinates at each of the sites, and so when I get back, this is probably going to be for the A-level ecology kids. They can draw a profile on working out the distance and the heights. We could even, look at some of the maps with contours on. So that was the second one. And then the third one, which I was very keen to do, we've not really been able to do very much. Our GCSE astronomy kids do a shadow stick experiment. If you take the shadow where it's shortest, that's your local noon. Now in the UK we use Greenwich as our local noon. Well, we're in Wolverhampton, so if we take our local noon, it's a few minutes behind Greenwich. And so you can calculate, because it's later than it should be, because we're using our watches on a time zone, but the actual precise local noon is later, so we can work out how far west we are. And so I wanted to do the same experiment in Iceland and then give it to the astronomy kids and say, this is the data I've got, where was I? And see if it actually ended up on Iceland. Haven't had the weather to be able to do that. We've had one morning and one evening where we managed to have a go. So what we've got is we've got stones laid out. We used one of the organisers as our shadow stick because he can keep running to the same spot and there was consistent height, we hope, over the day. So we've got the shadows in the morning and where they are, and we've got the shadows in the evening. Now what we're going to have to do is we're going to have to join those up in an arc, which we did with a tape measure, and you get a really nice arc. So then I'm going to give these pictures to the kids and let them construct the shadow stick and work it out. And then from how far behind Greenwich that is, we should be able to calculate the longitude and find we're on the same longitude as Iceland. So there's quite a lot of maths involved in that.